students, good morning. Welcome to Adarsh Vidyalaya Metric Higher Secondary School Andiyu Chemistry Online Class. Chemistry Online Class. Okay students, the Unit 1, Basic Concepts of Chemistry and Chemical Calculations. Today discuss about types of redox reactions. Types of redox reactions. The redox reactions are classified into 5 types. One is a combination reactions. Combination reactions. The second one is a decomposition reactions. Decomposition reactions. The third one is a displacement reaction. Displacement reaction. Displacement reactions. So displacement reactions are further classified into 2 types. One is a metal displacement reaction, another one is a non-metal displacement reaction. Metal displacement reaction, another one is a non-metal displacement reaction. So metal displacement reaction, உலோக இடப்பெயர்ச்சி வினை. Non-metal displacement reaction, அலோக இடப்பெயர்ச்சி வினைகள். Disproportionation reaction. The fourth one is disproportionation reaction. விகித சிதைவு வினை. விகித சிதைவு வினை. The last one is competitive electron transfer reaction. The competitive electron transfer reaction. Okay, electron பரிமாற்ற திறன் வினைகள். So the redox reactions are classified into 5 types: combination reaction, decomposition reaction, displacement reaction, disproportionation reaction, and competitive electron transfer reactions. The first one is combination reactions. இணை வினைகள். Combination reaction. இணை வினைகள். The redox reaction in which the two substances, carbon and oxygen. Carbon and oxygen. The two substances combine to form a single compound. Single compound. Two substances, carbon and oxygen, two substances combine to form a single compound is called combination reaction. Combination reaction. Carbon 0 to carbon plus 4. Carbon 0 to carbon plus 4. Okay. So loss of 4 electron. Loss of electron. Okay, 0 to plus 4. The oxidation number increases. Oxidation number increases. The loss of electron. Oxidation. Oxidation. Oxygen 0. Oxygen 0. 0 to. So each oxygen minus 2. So minus 4. 0 to minus 4. O2, O2. So 0 to minus 4. Gain of 4 electron. So gain of electron. Gain of electron. Reduction. Reduction is a redox reaction. The redox reaction in which the two substances combine to form a single compound is called combination reaction. Is called combination reaction. Alright. The next redox reaction is a decomposition reaction. Next types of redox reaction is decomposition reaction. Decomposition reactions. The redox reaction in which a compound breaks down. A compound, potassium chlorate, KClO3. KClO3. A compound breaks down into 2 or more components. 2 or more components. KCl and O2. Okay, the redox reaction in which a compound breaks down into 2 or more components. ஒரு சிங்கிள் காம்பவுண்ட் பிரேக் ஆகி ரெண்டு அளவுக்கு மேற்பட்ட காம்பனன்ட்ஸா ஃபார்ம் ஆகுறதுக்கு தான் சிதைவடையக்கூடிய வினைகள் அப்படின்னு பேரு. This reaction is opposite in combination reaction. So combination reactionல two substance single compound ஆ மாறுது, combine ஆகி இங்க single compound breaks ஆகி two or more components ஆ change ஆகுது. So this reaction is opposite in combination reactions, right? Okay, the combination reaction, the oxidation number of the different elements, the oxidation number of the different elements, potassium chloride KClO3, KClO3. Okay, so the decomposition reaction, a compound breaks into give two or more components, KCl plus O2, KCl plus O2. It's a combination reaction. In this combination reaction, the oxidation number of the different elements in the same substance, the different elements in the same substance is changed. For example, potassium chloride, oxygen, each oxygen 2 minus, so 6 minus, oxygen 6 minus, chlorine, potassium plus 1, so chlorine plus 5, right? So plus 5, chlorine plus 5 to chlorine Cl minus 1, K plus Cl minus 1. So plus 5 to minus 1, plus 5 to minus 1, plus 5 to 0, gain of 5 electron, and further gain of more than 1 electron to reach minus 1, Cl minus 1. So last gain of 6 electron, gain of 6 electron. So gain of electron reduction, gain of electron reduction. Okay, oxygen O3, so each oxygen 2 minus, each oxygen minus 2, so minus 2 to 0, minus 2 to 0, loss of 2 electron in each oxygen, so loss of electron oxidation. So oxidation process, so reduction process are carry on in same substance but different elements. So the oxidation number of the different elements, chlorine and oxygens, in the same substance, potassium chloride, is changed, plus 5 to minus 1, minus 2 to 0. Okay, so balance the reaction. Chlorine Cl plus 5 to Cl minus 1, Cl 5 to Cl minus 1, gain of 6 electron, gain of 6 electron. Okay, so reduction process. Oxygen O3, so each oxygen 2 minus, so 6 minus, O3 6 minus 2, O2 0, O2 0. Okay, so balance the number of atom in each side, 3 2, add an even number, so 3 and 2, 6 oxygen, 6 2 into 6, 12 minus 2 0, loss of 12 electron, loss of 12 electron. Right? So in the balanced equation, the loss of electron is equal to gain of electron. So loss of electron, oxidation process 12 electron, but gain of electron, reduction process 6 electron. So multiply with 2 in the reduction reaction. So 2Cl. Okay, 2 into 6, 12 electron and 2 Cl minus. You write So 12 electron cancel. 2Cl plus 5, 2O3, 6 minus. Okay, 2Cl plus 5, 2O3, 6 minus. Next, 2Cl minus, Cl minus 2. And 3O2, 3O2, right? So 2 potassium, 2 chlorine, 2 chlorine, and 6 oxygen, 6 oxygen. Okay, so balance the reaction. So the oxidation number of the different elements in the same substance is changed. The combination reaction is a combination reaction. The compound breaks into 2 or more compounds. Potassium chloride breaks to give potassium chloride and oxygen. Okay, so the oxidation number of the different elements, chlorine and oxygen, in the same substance is changed. Plus 5 to minus 1, minus 2 to 0. Okay, this reaction is combination reaction. The next, displacement reaction. The third type of redox reaction is displacement reaction. இடப்பெயர்ச்சி வினை. An ion in a compound or atom, an ion or atom in a compound is replaced by an ion or atom of another element. Okay, so ஒரு element இன்னொரு சொல்யூஷன்ல இருக்கக்கூடிய அயனை இடப்பெயர்ச்சி செய்யக்கூடிய தன்மையுடையதாக இருக்கும். For example, copper sulfate, CuSO4, copper sulfate solution, blue color copper sulfate solution. Okay, so zinc metal, zinc more reactive than copper. Zinc is more reactive than copper. So the zinc replaced the copper 2 plus ion to copper 0. Copper 2 plus to copper 0. Zinc 0 is converted into zinc sulfate 2 plus. The displacement reaction இடப்பெயர்ச்சி வினை. So zinc உள்ள வந்தோடனே more reactive zinc உள்ள வந்தோடனே copper metal வெளியில release ஆகுது. So an ion or atom in a compound is replaced by an ion or atom of another element. So copper 2 plus to copper 0, gain of electron. Gain of 2 electron. Okay, gain of electron reduction. Okay, so zinc 0 to zinc 2 plus. Okay, loss of 2 electron. Oxidation. Okay, it's a redox reaction. This process is reduction, this process is oxidation. Okay, so redox reaction in which an ion or atom in a compound is replaced by an ion or atom, okay, of another element. Okay, so copper sulfate solution la irukக்கூடிய copper 2 plus இன்னொரு zinc வந்து zinc 2 plus ஆ கன்வெர்ட் ஆகி copper 2 plus copper ஆ ரெடியூஸ் பண்ணுது. இந்த reaction தான் displacement reaction. The displacement reactions are further classified into two types. One is a metal displacement reaction, another one is a non-metal displacement reaction. Okay, the first one is metal displacement reactions. Metal displacement reaction. Place a zinc metal strip. Place a zinc metal strip. Zinc metal. Place a zinc metal strip in an aqueous copper sulfate solution. Aqueous copper sulfate solution. Okay, copper sulfate solution, zinc metal strip. So place a zinc metal strip in a copper sulfate, aqueous copper sulfate solution. Observe the solution. The intensity of blue color, is reduced. Reduce the intensity of blue color, and sometimes the disappear of the blue color. Okay, so lost the disappear of blue color. The zinc metal coated become the zinc metal. The blue color is disappears. The intensity of blue color is slowly reduced. Finally disappear. Become coated the copper metal. The bronze copper metal in the zinc metal strip. Zinc metal strip. Are you right? This reaction is metal displacement reaction. Copper sulfate solution, blue color copper sulfate solution, zinc colorless metal. Okay, so ash color metal, zinc. So zinc 0, copper 2 plus. Are you right? So zinc replaced the copper 2 plus ion to copper. So zinc 0 to zinc 2 plus ion, zinc sulfate, copper 2 plus to copper. Alright, copper 2 plus 2, copper 0, copper 2 plus 2, copper 0, gain of electron, reduction, right? So zinc 0 to zinc 2 plus, loss of electron, 2 electron, oxidation. Okay, the redox reaction. The oxidation and reductions are carry on in this place. Okay, so metal displacement. So zinc metal displaced with copper 2 plus ion to copper metal. So metal displacement reaction. So already balance in this reaction, loss of 2 electron and gain of 2 electron, copper 1, sulfate 1, zinc 1. Okay, right? So metal displacement reaction. Next, non-metal displacement reactions. The example, zinc reacts with hydrochloric acids. The zinc metal replaced with hydrogen. Zinc metal, hydrogen non-metal. So metal to non-metal. So non-metal displacement reaction. ஒரு non-metal displace பண்றதுதான் இந்த reaction. Okay, so give zinc chloride and hydrogen. Okay, zinc replaced with hydrogen in hydrochloric solution. Hydrogen chloride solution. Okay, zinc replaced with hydrogen in hydrochloric acid solution. Okay, right? So zinc to zinc 2 plus, loss of electron. Loss of how many electrons? Loss of 2 electrons. Loss of electron oxidation. H plus 2 0. Gain of electron. Reduction. Okay, this reaction is redox reaction, non-metal displacement reaction. Okay, so electron, both sides, the loss of electron in the balanced equation, the loss of electron is equal to gain of electron, loss of electron 2. So gain of electron 1, so multiply with 2. Okay, zinc chloride. So Cl2, 2H2. Okay, so non-metal displacement reaction. The fourth one is the types of redox reactions. The fourth one is disproportionation reaction. Disproportionation reaction. விகிதச்சிதைவுகள். So auto redox reaction. The same element involved in oxidation and reduction. Such a same element decrease the oxidation number and increase the oxidation number. So both increase and decrease the oxidation number in the same element. Okay. So the sum of the redox reaction, the same compound can undergo both oxidation and reduction. For example, H2O2. H2O2, hydrogen peroxide, decomposes with give H2O and O2, water and oxygen. In this reaction, the same compound can undergo both oxidation and reduction. The same element oxygen. The oxygen only involved in oxidation and reductions. Okay, the same elements both increase and decrease the oxidation number. Okay, so each hydrogen plus 1. So plus 1. Each oxygen minus 1. So minus 1 to minus 2. Okay, so gain of 1 electron. Gain of electron reduction. You write next O2 minus 2 O0 O2. So each oxygen minus 1 to 0. Or O2. So 2 minus 2, 0. Loss of electron. Oxidation. The same elements involve oxidation and reduction. The same compound can undergo both oxidation and reduction. Okay, so oxygen O minus 1, gain of electron to convert O to O minus 2, decrease the oxidation number and increase the oxidation number. The same elements involved in decrease the oxidation number and increase the oxidation number. This reaction is called disproportionation reaction. How to balance in this disproportionation reaction? Okay, so two half reaction. One is a reduction reaction, another one is a oxidation reaction. Okay, so O2, each oxygen minus 1, so minus 2. 2 O2 minus. Okay, gain of electron. So how many electron? So number of atom, oxygen 2, so 2. Minus 2 to 4 minus. Minus 2 to 4 minus 2 oxygen. So minus 2 to 4 minus, gain of 2 electron. So gain of electron reduction. The same element oxygen O2 2 minus 2 O2 0. Okay, so gain of electron, loss of electron. Oxygen 2. Okay, charge minus to 0. So loss of 2 electron. Loss of 2 electron. You write the loss of electron and gain of electrons are equal. So how many O2 2 minus? 2 O2 2 minus. 1 2 2 O2 2 minus. Right? Will give O2 minus 2 O 2 minus plus O2 0. Right? How many? O2 2 minus? O2 2 minus 2. 2. Okay. O2 minus. O2 minus 2. So O2 O2. Right? So balance the reaction. How many hydrogen? 4 hydrogen. 4 hydrogen. How many oxygen? 4 oxygen. 2 plus 2, 4 oxygen. So this reaction is disproportionation reaction. This reaction is disproportionation reaction. The same compound of the same molecules involved in both oxidation and reduction. Okay, the same elements decrease the oxidation number and increase the oxidation number. Correct? So another one example. So another one example. The first example. The second example. Chlorine reacts with potassium hydroxide. Chlorine reacts with potassium hydroxide. Potassium hydroxide give potassium chloride and potassium chlorate. Potassium chloride and potassium chlorate plus water. H2O. H2O. So potassium K plus. So oxygen 2 minus H plus or OH minus. Okay, so 2 minus 1 plus. OH minus K plus. Okay, balance the H. No change in potassium, oxygen, oxygen. So all equal charge, oxidation number. But chlorine 0. The same molecule can undergo both oxidation and reduction. Cl2 to Cl minus. Cl0 to minus 1 gain of electron. Gain of electron reduction. Gain of electron reduction. The next, the Cl2 to Cl. So each oxygen 2 minus 6 minus plus 1 chlorine plus 5. Chlorine plus 5. So 0 to plus 5 loss of electron. Loss of electron, oxidation. Gain of electron reduction and loss of electron oxidation. Right? The same molecules can undergo both oxidation and reduction. Okay, in such case, the same chlorine Cl2 decrease the oxidation number and increase the oxidation number. So both decrease and increase the oxidation number in same molecules, chlorine Cl2. Right? How to balance in this reaction? So separate two half reactions. So first one, reduction. Cl2 0 to reduction. Cl minus. Cl2 0 to Cl minus. Okay, how many chlorine? 2. 0 to 2 minus. Gain of 2 electron. So gain of 2 electron. It's a reduction process. Okay, next Cl2 0. Okay, Cl2 Cl plus 5, loss of electron, oxidation. Cl plus 5. Okay, how many chlorine? 2. Okay, 02 plus 10. So loss of 10 electron. Loss of 10 electron. In the balanced equation, the loss of electron is equal to gain of electron. So equation in the previous equation, the first equation multiply with the 5. So 5Cl2 plus 10 electron and 10 Cl minus. Okay, so add in these two reactions. 5 and 6 Cl2, right? So 6Cl2 okay, so 5 plus 1 6Cl2, 10 electron will give 2Cl plus 5 plus 10 Cl minus. Okay, so 6Cl2 plus KOH will give Cl minus 10 KCl plus Cl5 2Cl5 2KClO3 plus H2O. Okay, so balance the atom in both sides. Chlorine 6 chlorine, right? 12 chlorine. 6 into 2 12 chlorine. 10 plus 2 12 chlorine. Potassium 10 plus 2 12 potassium. 10 plus 2 12 potassium. Hydrogen 12 hydrogen, so 6 oxygen, 12 oxygen, 3 into 2 6 and 6 12 oxygens. Okay, so all number is even number, so multiply with the same, divided with the same number. Oh, minimum number 2. Okay, so 2 divided by 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 2. The correct balance equation is 3Cl2 plus 6KOH. 6KOH will give 5KCl plus KClO3 and 3H2O. So 6 chlorine, 5 plus 1. 6 chlorine, 6 potassium, 5 plus 1, 6 potassium, 6 oxygen, so 3, 6 oxygen, 6 hydrogen, 3 into 2, 6 hydrogen. Okay, so balance the correct equation. This reaction is disproportionation reaction. The same molecules involved in oxidation and reduction. Such a reaction, the same element decrease the oxidation number and increase the oxidation number. Of reactions, competitive electron transfer reaction. Electron பரிமாற்றத்திறன் வினை. Okay, already you know the metal displacement reaction. The zinc replace the copper 2 plus ion in copper sulfate solution. Zinc sulfate plus copper. Metal displacement reaction. The zinc replace copper 2 plus ion in copper sulfate solution. But in the reverse reaction, the copper metal strip placed in the zinc sulfate solution. Okay, so the zinc sulfate solution. The solution is zinc sulfate, aqueous zinc sulfate solution. Strip in a copper, strip in a copper. Say copper metal strip placed in the zinc sulfate solution. Okay, so suppose copper is highly reactive than zinc, the solution is converted into copper sulfate. So copper sulfate plus zinc, the solution turn into blue color. Observe the solution cannot change in this color. So the copper cannot replace the zinc 2 plus in zinc sulfate solution. Not possible in this reaction. Are you right? So not possible in this reaction. This reaction so cannot take place. No reaction. So zinc is more tendency to release the electron than copper. In other way, copper placed in silver nitrate solution. Okay, so taken in a silver nitrate solution beaker. So in a beaker contain silver nitrate solution AgNO3. Place a copper metal strip. Place a copper metal strip in this solution. Okay, so observe the solution. The intensity of blue color is increases. So the reaction is carry on. So copper converted into copper nitrate solution. The silver ion to silver metal. Right? So NO3 twice, 2, right? Copper to copper 2 plus. Loss of electron, oxidation. Ag plus 2, Ag 0. So gain of electron, reduction. In this reaction, the copper is more tendency to release the electron than silver. Okay, so releasing tendency of electron series in these three metals, zinc is more releasing electron than copper. The copper releasing than silver. The electron releasing tendency of copper is less than zinc and more than silver. The electron releasing tendency of silver is less than copper and zinc. Okay, when a electrochemical series, lithium, potassium, sodium, calcium, magnesium, aluminum, zinc, tin, lead, hydrogen, based on hydrogen, copper, mercury, silver, gold, platinum. Based on hydrogen, in above the hydrogen, the tendency of releasing electron is increases. In below the series. Below the series, the tendency of electron releasing decreases. The electron releasing tendencies decreases. In top to bottom, the electron releasing tendencies decreases. The bottom to top to increase the electron releasing tendency. So the electrochemical series easily identified to involve oxidation and reduction reactions. So metal displacement reaction is possible or not? You know in this series. Okay. So copper is highly electron releasing tendency than silver. But zinc and copper, the copper is less releasing electron tendencies than zinc. So copper is electron releasing tendency is less than zinc. But zinc is more tendency to electron releasing. The electron releasing tendency is more than copper and silver. Right? Okay. So copper, silver nitrate, auric chloride. So silver Ag reacts with chlorine AuCl3, auric chloride, to give silver chloride in high temperature. Silver chloride to gold. Right? AgCl 3 times. Okay, so 3. Okay, students. Okay, so competitive electron transfer reactions. எலக்ட்ரான பரிமாற்றம் செய்யக்கூடிய திறன், எதுக்கு எலக்ட்ரான ரிலீஸ் பண்ணக்கூடிய திறன் அதிகமா இருக்கோ அது இன்னொரு சொல்யூஷன்ல இருக்கக்கூடிய மெட்டல் அயான்ஸ மெட்டலா கன்வெர்ட் பண்ணும். இப்ப இந்த ரியாக்ஷன்ல பாத்தீங்க அப்படின்னா ஜிங்குக்கு எலக்ட்ரான் ரிலீஸ் பண்ணக்கூடிய திறன் காப்பரை விட அதிகம். அதனால காப்பர் சல்பேட்ல இருக்கக்கூடிய காப்பர் 2+ அயனிய காப்பரா மாற்றக்கூடிய டெண்டன்சிக்கு ஜிங்குக்கு இருக்கு. சோ ஜிங்க் சல்பேட் ஆகும். காப்பர் 2+ இருந்தது காப்பராவும் ரிலீஸ் ஆகுது. பட் ஆனா காப்பரை கொண்டு போய் ஜிங்க் சல்பேட் சொல்யூஷனுக்குள்ள வச்சோம் அப்படின்னா ஜிங்க் சல்பேட் இஸ் மோர் ரிலீசிங் டெண்டன்சி ஆஃப் எலக்ட்ரான் தென் காப்பர். சோ காப்பரை விட ஜிங்குக்கு தான் எலக்ட்ரானை ரிலீஸ் பண்ணக்கூடிய டெண்டன்சி அதிகமா இருக்கும். அதனால இந்த ரியாக்ஷன் நடக்காது. ஓகே, சோ இதே காப்பரை சில்வர் நைட்ரேட் சொல்யூஷனுக்குள்ள வைக்கும்போது அந்த ரியாக்ஷன் நடக்குது. அப்போ ஒரு ரியாக்ஷன் நடக்கணும் அப்படின்னா அந்த ரெண்டு மெட்டல்ல எதுக்கு எலக்ட்ரானை ரிலீஸ் பண்ணக்கூடிய டெண்டன்சி அதிகமா இருக்கோ அதுதான் ஓகேவா. சோ இன்னொரு சொல்யூஷன்ல இருக்கக்கூடிய மெட்டல் அயான்ஸ மெட்டலா ரிலீஸ் பண்ணும். ரைட்? சோ அந்த ஆர்டர் தான் இது. ஹைட்ரஜனுக்கு மேல இருக்கக்கூடிய லித்தியம், பொட்டாசியம், சோடியம், கால்சியம், மெக்னீசியம், அலுமினியம், ஜிங்க், டின், லெட் இதெல்லாம் ஈஸியா எலக்ட்ரானை ரிலீஸ் பண்ணக்கூடிய டெண்டன்சி, ஆக்சிடேஷன் ஆகும், ரெடியூசிங் ஏஜென்ட் ஆக்ட் பண்ணும். சோ இங்க கீழே இருக்கிறது எல்லாமே ஹைட்ரஜனுக்கு கீழே இருக்கிறது எல்லாமே எலக்ட்ரானை ஈஸியா அக்செப்ட் பண்ணும். சோ அதனால ரெடியூஸ் ஆகும், ஆக்சிடைசிங் ஏஜென்ட் ஆக்ட் பண்ணும். Right? So very important 5 mark question. The types of redox reaction. Is a very important 5 mark questions. So each type 3 mark or 2 mark questions. So study well. Thank you students. We'll meet next class.